Hey guys, welcome back to part 2 of section 1.2 of our AP Calculus Summer Review. Here are the things that we're going to talk about to finish up section 1.2. First, we're going to identify some common functions that you should be able to recognize from their graphs. We're going to interpret and find formulas for piecewise functions, and we're also going to work writing and evaluating compositions of two functions. Okay, so here we go. These are 7 common functions that you should recognize by sight. So what I would like you to do is take a minute and in your notes, please make a quick sketch of each of these 7 functions. And after you've sketched them, I'd like you to identify the family that they represent, whether that be quadratics or absolute values or whatever. But just go ahead and make a quick sketch of each of these 7 functions and try to identify what family each of them represents. Pause the video to do that, and then when you come back, I will have the answers for you. Okay, here are your answers. In order, going across the top, first of course is our linear, then our quadratic. Next right here is our cubic function. This is the reciprocal function. This is our square root function, followed by cube root, and lastly our absolute value family. Okay, so hopefully you got all of those correct and you're remembering what those families of functions look like. Okay, next thing we're going to talk about is graphing piecewise functions. Of course, you know, we could sketch a graph of these, but what I'd like to do is I'd like to take a couple of minutes to show you how to do this on our TI Inspires. So I'm going to get out of my PowerPoint here and I'm going to pop up my TI Inspire to show you how to you can see what the graphs of each of these are going to look like, but I'd like to show you how to enter this information on your graph. Okay, so first off, it is a graph, so from our home screen we're going to select graph, and then we need to get a piecewise function. It's not just an f1 of x. That's not going to work because our piecewise function is defined by those 2 different parts dependent upon where we are here in the domain. So to get a piecewise function, we're actually going to hit this little catalog button, which is right next to the book sign. So we're going to hit that, and then you'll see all of these different options pop up. And these 2 here are your piecewise. Actually, there's a few piecewise values here, but we're looking for this one here because our first function has 2 different functions defined, and we also need to be able to input those domains. So we're going to click on this and hit enter. And then you'll see down here, here's the window where we can enter our information. So the first function is x squared for x is less than 1. So I'm going to type in x, hit my little squared, minus 2. And then that domain is x is less than 1, so x. And then to get the less than, we're going to hit control and the equals, and you can see in blue how those equality and inequality signs are in there, so we need that, and we're looking for less than, so x less than 1. And then I'm going to arrow down to get to my next row. So okay, our second function is x plus 1, so just enter that using the keypad, x plus 1, arrow over to the domain, and this is for x is greater than or equal to 1, so x. Again, control and equals gets us our inequalities. We're looking for the greater than or equal to, there it is, 1, and that's everything that we need. So we're going to hit enter, and there you go. You can see the graph on my screen pop up as a graph of that quadratic for x is less than 1, and then picking up at 1 with the linear function. So that's how we enter the piecewise. I'm going to go ahead and clear that out. I don't need it, and we're going to move on to our second piecewise. So we're going to open up a graph. Again, I'm going to hit my catalog button so that I can enter my piecewise. This time I need to move over to the next one because this time my piecewise function has 3 pieces. So there's our 3-part piecewise. We're going to enter. And this would actually allow you to enter more than 3 pieces, but we're going to leave it at that default 3 because that's what we need. Hit OK. Okay, our first function is simply x for our first domain value of x is less than -2, so x, control, and the equals, less than -2, make sure you hit the negative here, not the subtract. That's going to give you a syntax error, but make sure you hit that -2. And then I'm going to arrow down to get to my second piece of my piecewise function, and that's x minus 1. So x minus 1. Arrow over to get my domain for -2 is less than or equal to x is less than or equal to 1. So -2, control equals, grab my less than or equals, x, control equals to grab my next less than or equals, and then 1. Okay, I'm going to arrow down to get to the third piece of my piecewise function, and that's x squared, so x squared. Arrow over to the domain entry for x is greater than 1, so x, control equals, we're going to grab the greater than 1, and then we're going to hit enter. And there you go. You can see the graph that I have here matches this graph here as well, so that's what the picture of that piecewise function would look like. So that's how you're going to use our technology to graph the piecewise function. So what I would like you to do, let me get rid of this, get back into our PowerPoint, and again, there are the pictures of the two that we just graphed. I'd like you to take a minute. I want you to try to graph this one on your own. So go ahead, pause the video, graph this piecewise function, and then start the video again, come back and check for your answer. Okay, here we are. This is what hopefully your graph looks like. We have the negative x function here, followed by the quadratic right here between 0 and 1, and then the constant from 1 on. So hopefully you were successful and you were able to generate that piecewise function. Okay, here we're going to talk about some translations of functions. Of course, we could throw this into our Inspire and have that graph it for us. But before we do that, I want to take a minute and just talk about what is happening when we do these translations. So here's our standard absolute value of x function, and this is just going to be a translation of that. So think back to what you know about translations of functions. Remember this -1 here on the outside, this subtracting 1. On the outside, that's going to be a vertical shift. So this -1 is going to move our vertex down from the origin 1 unit. And then on the inside of the absolute value bars here, this x minus 2 is going to be a horizontal shift. And it's a bit counterintuitive. It says -2, but remember that actually moves it over 2 to the right. So the vertex of our parabola is going to be shifted down 1 and 2 over to the right. So it's going to land right there. And that's a graph of that translated absolute value function. But what I am going to do is I'm going to show you how to enter an absolute value into your Inspire, just so you know how to graph one of those if you encounter one that you need to graph. So, okay, we're going to go ahead, get a graph, and what I need again is my catalog button. I need my absolute value bars, which is the first choice on the second line here. So we're going to grab that, hit enter. And inside our absolute value bars was x minus 2, and then arrow over to get outside of those absolute value bars, -1. And we're going to hit the enter there, and there you can see there is our parabola with the vertex shifted down 1 over 2. Okay, here we go. Get back where we were. And move on to our last piece. We're going to talk about composition of functions. We're going to define g of x to be x squared and f of x to be x minus 7. And you remember composing functions is putting one function into another function. So we're going to first find a formula for f of g of x, or f composed with g of x. And then we're going to find the value for f of g of 2. So first we're going to put the g of x function value into the f function. So g of x is x squared, and we're going to put that into f of x. So f of g of x is the same as f of x squared, because that's the g of x value. And then f of x takes x and subtracts 7. So f of x squared is going to be x squared minus 7. Okay, we're going to use this formula to calculate the value of f of g of 2. So f of g of 2 simply substitutes 2 in for our x value, so 2 squared minus 7, which gives us a value of negative 3. Okay, next we're going to do sort of the opposite of that. We're going to find g composed with f, so g of f of x. That means we're going to put our f of x function, this x minus 7, into the g function, and the g function squares it. So g of f of x is g of x minus 7, which simply takes that quantity x minus 7 and squares it. Certainly you could go ahead and expand that out in polynomial form and get the x squared minus 14x plus 49 if you would like. You can just leave it like x minus 7, the quantity squared, that's fine. And then we're going to go ahead and substitute 2 in, so g of f of 2 is 2 minus 7, that quantity squared, so that's going to be equal to 25. Okay, and that finishes up the last couple of topics we had to finish in section 1-2. This is a list of the homework problems for section 1-2 on pages 19 and 20 in your book. The following numbers 31, 33, 41, 42, 45, 51, 55, and 61. Good luck with these. If you have a question or need help or want to check in, again, please drop me an email. I'll be happy to hear from you, and I'll get back to you shortly. Okay, good luck, and I will see you soon for lesson 1-3.